Isaac Newton, born in 1643 in England, was a remarkable man. He was a physicist, a mathematician and an astronomer. He is considered one of the most influential scientists of all time. His discoveries changed the way we understand the universe. Newton was a curious child. From a young age, he showed a keen interest in how things worked. He built models and conducted experiments. His inquisitive nature laid the foundation for his groundbreaking discoveries later in life. Newton attended Trinity College, Cambridge. At Cambridge, he immersed himself in his studies. He was particularly drawn to mathematics and physics. He spent countless hours studying the works of great thinkers who came before him. Despite the academic rigour, Newton's time at Cambridge was not without its challenges. The plague forced the university to close temporarily. During this time, Newton returned home and continued his studies independently. It was during this period that he made some of his most important breakthroughs. One of Newton's most significant contributions was his three laws of motion. These laws form the foundation of classical mechanics and have been instrumental in advancing our understanding of the physical universe. Newton's insights were groundbreaking, providing a framework that scientists and engineers still rely on today. These laws, published in his book Principia Mathematica, explained how objects move and interact with forces. The Principia Mathematica is considered one of the most important works in the history of science, laying the groundwork for much of modern physics. Newton's meticulous work in this book has inspired countless scientists and researchers over the centuries. The first law states that an object at rest will remain at rest, and an object in motion will stay in motion unless acted upon by a force. This principle, often referred to as the law of inertia, helps us understand why we need to apply force to change the motion of objects. It explains everyday phenomena, such as why a car needs to accelerate to start moving and why it continues to move even after the engine is turned off. The second law explains how force, mass and acceleration are related. It states that the force acting on an object is equal to the mass of that object times its acceleration. This law is crucial for understanding how different forces affect the motion of objects. For instance, it helps us calculate the amount of force needed to propel a rocket into space or to stop a speeding car. The third law states that for every action there is an equal and opposite reaction. This principle is evident in many aspects of our daily lives, from the way we walk to the functioning of jet engines. When you push against a wall, the wall pushes back with equal force. This law is fundamental in understanding the interactions between objects and forces. These laws revolutionized our understanding of the physical world. They provided a clear and concise explanation of the principles governing motion and force, paving the way for future scientific discoveries. Newton's laws of motion are not just historical artifacts. They continue to be relevant and are applied in various fields, from engineering to space exploration. Their impact on science and technology is immeasurable, making them a cornerstone of modern physics. Section 4. The Apple and the Moon. Newton's Law of Universal Gravitation. Perhaps Newton's most famous discovery is the law of universal gravitation. This law fundamentally changed our understanding of the universe and how it operates. Before Newton, the motion of celestial bodies and the behavior of objects on Earth were thought to be governed by different sets of rules. Newton unified these concepts with a single elegant theory. Legend has it that Newton was inspired by an apple falling from a tree. This simple observation led him to ponder the forces at play. He questioned why the apple fell straight down and not sideways or upwards. This curiosity sparked a series of thoughts that would eventually lead to his groundbreaking theory. He realized that the same force that pulled the apple to the ground also kept the moon in orbit around the Earth. This was a revolutionary idea at the time. Newton's insight was that gravity is a universal force, acting not just on Earth but throughout the cosmos. This force is what keeps the planets in their orbits around the Sun and governs the motion of all celestial bodies. This groundbreaking idea explained why planets orbit stars and why objects fall to the ground. Newton's law of universal gravitation provided a framework that could predict the motion of planets and other celestial bodies with remarkable accuracy. It was a unifying theory that brought together the heavens and the earth under a single coherent set of principles. The law of universal gravitation states that every object in the universe attracts every other object with a force that depends on their masses and the distance between them. This means that the gravitational pull between two objects increases with their mass and decreases with the square of the distance between them. Newton's formulation of this law was a monumental achievement, laying the groundwork for modern physics and astronomy. His work continues to influence scientific thought to this day, demonstrating the enduring power of his insights. Section 5. A revolutionary telescope and the nature of light. Newton's contributions extended beyond mechanics and gravity. He made significant advances in optics. He invented the reflecting telescope. This type of telescope used mirrors instead of lenses. Newton's telescope solved problems that plagued earlier telescopes. It produced clearer images. This invention revolutionized astronomy. Newton also conducted experiments to understand the nature of light. He demonstrated that white light is composed of a spectrum of colors. Section 6. The enduring legacy of a scientific giant. Isaac Newton's discoveries had a profound impact on science and the world. His work laid the foundation for classical physics. His contributions extended to mathematics, where he developed calculus. Newton's ideas influenced generations of scientists and thinkers. His laws of motion and gravitation are still used today by engineers, physicists, and astronomers. His work continues to inspire and shape our understanding of the universe. Section 7. Inspired by genius, a call to exploration. Isaac Newton's life and work are a testament to the power of curiosity and the pursuit of knowledge. Born in 1643, Newton's early years were marked by a relentless quest for understanding. His fascination with the natural world led him to question, to experiment, and to seek answers that were not immediately apparent. His groundbreaking discoveries reshaped our understanding of the natural world. The story of the falling apple is legendary, symbolizing his insight into gravity, but his contributions went far beyond that single moment. His work in mathematics, optics, and astronomy laid the foundation for modern science. His story is an inspiration to us all. Newton's dedication to learning and his ability to see the world through a different lens remind us of the importance of perseverance and creativity. His legacy lives on in the countless students and scholars who continue to be inspired by his work. I encourage you to learn more about Isaac Newton and his remarkable contributions. Explore his life, his experiments, and his enduring legacy. Visit museums, read his works, and delve into the history of his discoveries. Each piece of his story offers a glimpse into the mind of a genius. Delve into the world of science and discovery. The spirit of exploration that drove Newton is still alive today. In modern laboratories, in classrooms, and in the curious minds of young learners, the quest for knowledge continues. You might just be surprised by what you find. Whether it's a new scientific principle or a deeper understanding of the world around you, the journey of discovery is always rewarding. So take that first step and let your curiosity lead the way. If you enjoyed this exploration into the life of Isaac Newton, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Keep exploring.